pleasure to introduce Kate MacQuarrie, who I'm sure all of you know. One more thing I forgot to mention about Helena is, for more information, her website is sevenfiresanctuary.com. All one word. Yes. Okay. So a little bit of background. I'm looking. Kate is an award-winning biologist, naturalist, and author for Prince Edward Island. And through her research in forests and coastal sand dunes, she's identified plant species not previously known to exist on the island, and has published work in national and international journals. She's served as PEI's Director of Forests, Fish, and Wildlife since 2003, and previously led the Island Nature Trust for 8 years. Lots of experience, eh? She was also the founder of PEI Untamed and the author of Wild Foods of Prince Edward Island, which you can see in many places. Kate has been foraging and studying local wild plants for more than 3 decades and specializes in plant identification, natural history, and ecological education. Through her programs and workshops, she helps people reconnect with the natural world around them, and I'm sure many of you have been on her explorations in those workshops. And of course, you can always consult PEI-untamed.com. So welcome, Kate.
Thanks for that introduction, and welcome everybody. I wanted to talk about fungi today, because I think when we think about products or opportunities in our forests, trees are the first thing that come to mind. And then maybe plants and medicinal plants that Helena talked about. And maybe wildlife, but often fungi are way down the list if they're on the list at all. And it's a good opportunity for us to connect to our own forests, to explore forests here in Prince Edward Island and throughout the Maritimes, and there's economic opportunities to be had as well. We have hundreds of known species of fungi on Prince Edward Island, and there's probably thousands more. Fungi are an understudied group on PEI, even with some of the recent research that's been done here. So there's lots of new opportunities to be found. I'm a botanist by training, and people sometimes expect me to be an expert in fungi, and are surprised when I tell them that fungi are more closely related to animals than they are to plants. I think if we're looking for life in the universe, we should start looking for fungi because they're very, very alien-like. Here in North America, we're prone to mycophobia, or being afraid of fungi. And sometimes when I get photos from people to identify, it'll be a photo of a gloved hand holding a mushroom because they're afraid to touch it. My friends from Europe, and especially my Asian friends, are very excited about fungi, and it's much more part of their culture than it is here in North America. In my own family, my maternal grandfather was one of the island's fungal experts back in the 1940s and 50s, and he passed away before I was born, so I never got to know him. But my grandmother was terrified of the mushrooms that he'd bring home. So she didn't eat them, and she wouldn't let the kids, so my mom and my aunts and uncles didn't get to experience them. So that knowledge was lost, and I really wish I had an opportunity to know him and get that knowledge from him, but trying to regain it now. A story that Helena would be familiar with too. I'm just going to look at about 20 beginner-level species today, and I want to talk about some of their ecological roles as well as some of the ways that we can use them. The photos in the presentation are all local fungi photos that I took, unless the credits are there. So I want to start out with what is a mushroom, which is often a little bit misunderstood. The mushroom, the thing that we see above the ground or growing from the tree, isn't the organism itself, it's the fruiting body of the organism, often described like an apple on a tree. The mushroom itself, the living organism, is in mycorrhizae, living inside the soil or inside a tree or often on a different plant. So the biology of fungi is very different than the biology of plants, and sustainability of fungi is a very different concept than sustainability of plants. When you're picking a mushroom, it's like picking an apple. The tree doesn't care if you pick half of its apples or one of its apples or all of its apples. It just wants to use those to spread the seeds. The mushrooms are the same way. The apple doesn't care whether you cut it off the tree or pluck it. And I can usually get a good argument going by saying, cut mushrooms, don't pluck them, you're pulling up the roots, right? No, that's not true. That's true of plants, much, much different situation. Mushrooms, pluck them, cut them, however you like. Doesn't mean that sustainability isn't important, it just means it's a different concept with fungi than it is with plants. Mushroom identification, so often I get a photo like you see on the left there. And it's very true that if I gave you the top of somebody's head, would you be able to identify that person? Probably not. The same is true of mushrooms. Just like to identify me, you need to see all of me within the limits. To identify mushrooms, you need to see all of their parts. So the cap, the top, what we call the pileus. What's its shape? What's its color? What's its texture? Does it have decorations like warts or scales or other things on it? What's the spore-bearing surface? Underneath the cap, if it's a cap and stem mushroom, will be the part that holds the reproductive structures, sort of the equivalent of seeds in plants. So is it gills? Is it sponge? Is it teeth? Is it none of the above and something totally different? That helps classify your fungi. What's the stem look like? Is it solid? Is it hollow? Does it have decorations or scales or warts? Does it change color when you poke it? Does it smell funny? What's that look like? And for some groups, the base is really important, and sometimes it's important to dig the mushroom up so you can get a good look at that base, especially for some of our most toxic fungi. So what's its shape, and are the mycelia attached? All of those things are important. For many fungi, it's virtually impossible to identify just from a single photo. You need pictures and angles and cross-sections. And fungi are fantastic because we use all our senses to identify them. If you've been on a walk with me, I encourage you to use taste and touch and smell and sight, everything. And the same is true of fungi. So substrate, is your fungus growing from the ground or from a tree? If it's growing from the ground, is it growing from the soil or from a piece of wood buried in the soil? If it's growing from a tree, what species? Is it hardwood, softwood? Is it birch or maple? Is the tree alive or dead? All of those things are important to note. Color change can be important, especially in the boletes. Boletes are a group that primarily have spongy pores under the caps rather than gills or teeth. And often, whether they change color, and that one in the center, I've just stuck my finger on it 3 times. I'm sure you could get my fingerprint from it if you were so inclined. What's the taste and smell? No mushroom can hurt you unless you swallow it. And for some mushrooms, taste is a really important indicator. The mushroom I've shown on the right is called peppery bolete. And if you take a nibble of it, it'll have a very pleasant peppery flavor, but spit it out. That's actually edible, so that one would be okay. But if you're not sure of a mushroom, taste, especially with some of the rucolas, taste can be an important indicator. Just chew it up and spit it out. It can't hurt you. No mushroom can hurt you if you touch it, only if you ingest it. Going back to the mycophobia comment, I don't like people to be afraid of anything in nature, but plants are more threatening than fungi, right? Plants can burn you, they can sting you, they can cut you. No mushroom can do that. So I want to talk about their ecological roles, because while I do talk about some edible fungi, and I'll show you some that you may have in your woodlots, I'm much more interested in their ecology. And fungi make a living in 3 main ways. And the first way is through partnerships. Mycorrhizal fungi, this is a brown birch bolete, and it forms partners with birch trees, both white and yellow birch. So if you have birch in your woodlot, take a look for it. This is one of the so-called scaber stalks. If you look at the stem on that mushroom, it looks like it has a 5 o'clock shadow. That's an identifying feature of that group. Mycorrhizal fungi form partnerships with trees and other plants. Fungi can't photosynthesize, they can't make food from sunlight, but trees can. So mycorrhizal fungi are taking some of those sugars, some of the carbohydrates that the tree is making through photosynthesis, and using it as food. But it's not a one-way deal. The fungi is also giving back to the tree water and nutrients that it's taking up. So it's a partnership. And it's been shown in some cases that fungi play important roles in allowing trees to grow, especially in challenging habitats. They're making the nutrients more accessible to those trees. They can also help with disease resistance and environmental stress. But mycorrhizal fungi aren't just important for trees. They're important for lots of the plants in your woodlot as well. They form relationships with other plants. Some of these are very species specific, some are more general. Orchids are a good example. Orchids are an ancient group of plants, and they evolved before plants figured out that having a package of food attached to their seed is a good strategy. So orchid seeds are tiny, they look like dust, and they don't have that food packet to help them get going, and instead they rely on fungi. So most orchids don't germinate without a fungal partner to provide those nutrients to them. So if you have lady slippers in your woodlot, you can thank some of the mushrooms that are growing there. One of my favorite plants is ghost pipe, and it's a member of the blueberry family. Y'all would have recognized that as a blueberry, right? Ghost pipe is one of our plants that lacks chlorophyll. It's not a mushroom, but like mushrooms, it can't make food from sunlight, and instead it taps in to that relationship between fungi and trees, and it steals some of that two-way trading network products for itself. And ghost pipe is also a tremendously important medicinal plant, probably one of our most powerful medicinal plants on PEI. So fungi can be partners, and sometimes they can be parasites. And parasite in our common language is kind of a bad thing. If somebody's a parasite, you probably aren't going to think too highly of them. In nature, parasites play really important ecological roles. This is a honey mushroom, an armillaria. Honey mushrooms cause shoestring root rot in forests. So if you see honey mushrooms in your woods, your trees are on the downside. They're on the decline, and there's not much that you can do to change that. There's no inoculation or a way to get rid of armillaria. But you don't need to. It's helping with the succession of that forest and killing off trees that are going to become standing dead trees, that are going to be so important for invertebrates and fungi and wildlife of all sorts. You like that one, Julie Lynn? Julie Lynn appreciates the fly death fungus. Fungi aren't just parasites on plants, but they can be parasites on animals as well. And shown there, you see a little fly that's kind of spread eagle under an alternate-leaved dogwood leaf. And it's all fuzzy and white. And that fuzzy white is a fungus that we have on PEI, appropriately called fly death fungus. And it infects a fly, and it takes over its brain. It turns the fly into a zombie. And it causes the fly to crawl up plant material. I always see them at this level, but that could be a function of that's where I see stuff, right? That's where my eyes are. And it causes them to go spread eagle under the plants, and then it releases its spores, which is a fantastic adaptation. So imagine you've got a handful of dust, 2 handfuls, 1 in each hand. This one you released at ground level, and this one you release up here. Which one's going to spread further, right? So fantastic adaptation. And if you don't like flies around, a little bit of population control. We think of fungi very often as decomposers. And if you're happy sitting in a room or walking through your woods where you didn't have to wade through meters of dead stuff, plants and animals around you, thank the decomposers. These are our waste disposal services and our recyclers. And they operate in a bunch of different ways. On the left is turkey tail, and I'll talk a bit more about that in a moment, and that's a white rot decomposer. I'll tell you what that means in a sec. In the middle is green elf cup, and it's a soft rot decomposer. And on the right is red belted polypore, which is a brown rot decomposer, and each of those plays a different ecological role in your forest. White rot wood is primarily made up of two components, cellulose and lignin. White rot decomposers decompose lignin and leave behind cellulose. Cellulose is a carbohydrate that's super important to nutrient cycling in the forest. Other fungi and animals and plants can use that cellulose. On the right-hand side, you've probably all seen that brown cubicle rot in your forest. That's from a brown rot decomposer. That's lignin left behind. Lignin is super durable, and it goes into the forest soil, and it provides structure and relates to carbon storage. Whenever we talk about carbon storage in forests, so often we look at just the trees and maybe the plants themselves, but the soil is a super important source of carbon storage, and we can thank our fungi and our lignin for that. And in the center is the green elf cup, doing some of its soft rot. It's a separate type of decomposer that moves into slightly rotted wood, but you may have seen this in your forest, and if not, look for it. There's this beautiful green, and that's not an augmented color, that beautiful blue-green color it leaves in wood, and which throughout history has been used in artwork, in intarsia, and inlaid wood to give a natural color to the products. Okay, you're all saying, stop with the ecology, tell us what we can eat already. Before I do that, just some precautions. Obviously be 100% sure of your identification. We have some of the most toxic fungi in North America on PEI. We absolutely have fungi that can kill you if you swallow them. Don't hold that against them. We have some of the most toxic plants on PEI that can kill you if you swallow them as well. Rely on humans, not apps. People ask me what's the best plant ID app. I don't recommend plant ID apps. The best apps for plants, fungi are even less accurate. The best plant ID apps are 85% accurate. Helena, if I gave you a plant to eat and I said there's a 15% chance this could kill you, you probably wouldn't take that, would you?
I'd take some,
but you wouldn't, exactly. So rely on humans, and there's lots of good groups and sources around I can share afterwards. Cook mushrooms well. Mushrooms are high in lignin, or chitin rather. Mushrooms are high in chitin. Chitin is not easily digested by mammals. Cooking breaks down chitin. Same is true of store-bought mushrooms. It won't kill you if you eat them raw, if it's an edible mushroom. It can give you gastrointestinal upset. And always try a small amount first. Same is true of any new food. Your first feed of blueberries in the year probably go through you pretty quick. If you haven't been eating them for a while, try a small amount first. Okay. In terms of edible mushrooms, one of the most commonly sought after edibles are chanterelles, common across Prince Edward Island. I see them primarily under old-field white spruce with mossy ground behind them. That golden color, some of the guidebooks will talk about scent. I find that too subjective. I look for the golden color, those folds underneath the cap. Most importantly for me, when I cut them open, inside they're solid, white, with a texture like string cheese. None of our other mushrooms look like that. This is a great mild mushroom, great for beginners. We have a couple of other chanterelle relatives that you might have if you have a wetter softwood type forest. On the left-hand side is winter chanterelle, also called yellowfoot because of that yellow stem, very distinctive. On the right-hand side is one of my favorites, it's black trumpets. And black trumpet, the flavor is so strong, I don't like to waste it just eating them as is. I dry them and use them as a seasoning instead. Puffballs, super easy to find. All of our puffballs are edible. I'm going to show you how to tell it's not a toxic earth ball in a moment. Puffballs can be smooth like a light bulb that you see on the left-hand side, or they can have little decorations on their caps. You can find them in fields, roadsides, along trails, in every type of woodland, depending on the species in question. Puffballs, they're round, they don't have any spore-bearing surfaces on the outside, but you want to be sure that they're solid white inside. So on the left-hand side is an edible puffball, looks like a block of tofu, solid white. On the right-hand side is an earth ball, And you can see that inside that's dark. That doesn't look edible. You want your puffballs solid white. King boletes, tremendously common on Prince Edward Island. Some of you may know these as porcini or porcini mushrooms. If you're lucky enough to find them dried in the supermarket, you're going to pay a fortune for them. These photos, some of these are taken on my property. One of them is taken right outside my office window at Upton. Julie Lynn, there's a secret. King boletes are fantastic gourmet mushrooms. Again, boletes typically, not always, but typically have those spongy pores rather than gills under the cap. King bolete does not change color if you break it apart. And most importantly, it's going to be a little hard to see with the light here. At the top of the stem is some raised white net-like pattern, which is indicative of king boletes. All of these, I'll give you my website at the end, and there's more info and photos on my website. Honey mushrooms, these are the parasite, the shoestring root rot that I talked about. They're also one of my favorite edible mushrooms. I describe these as the bacon of the forest. They have that rich, fatty flavor to them. They start out little balls with kind of spikes on them. As they open up, they look quite different, but that spiky covering is still present in the center. Underneath, the stem is dark, and it has a ring on it. You want to be sure, there's a couple of things that look like these. A key indicator is the spore print on these is white. So if you're not sure, take them home, put them on a piece of paper. I like to do like a bit of a dark and light pattern if I'm not sure what the spore color is. Cover it so the wind doesn't damage it, or in my case, my cat doesn't knock it on the floor. And a couple of hours later, it'll have dropped the spores and you can see the print. People ask, is my time okay? Okay, well, just want to double check. Oh, perfect. People often don't realize that we have morels on Prince Edward Island. We don't know how common they are. I made a specific point of looking for morels last spring. These are one of our spring mushrooms. The rule is when you see the buds starting to appear on the lilacs, start looking for morels. They're strongly associated with apple trees, also with oak and elm. I have only found them associated with apples myself. So I made a point of looking for them last spring. Prior to that, there was only one confirmed location on PEI. I found 5 more last year, so they're certainly much more common than we expect. People are sometimes afraid of morels because there's a mushroom called a false morel, which is a terrible name for that mushroom. It looks nothing like a morel. That's the one on the right-hand side. Its genus is Gyromitra, and I prefer to call it Gyromitra because false morel is a misnomer. It's like me, I'm going to pick on Julie Lynn, it's like me calling me a false Julie Lynn. We don't look anything alike. Morels are fantastic, edible, a real choice mushroom. Gyromitras, some of them are edible with processing. I don't recommend them for beginners. They actually have a chemical in them that, when distilled, this isn't their original source, is used as jet fuel. So probably not something, or rocket fuel, probably not something that you want to ingest. It can be removed from the mushroom through processing, just not a good beginner mushroom. Oyster mushrooms, a fantastic edible choice mushroom on the left-hand side. Oyster mushrooms, the edible oysters grow primarily on poplar trees. Sometimes you'll find them on other hardwoods. They grow out the side of the tree, so they've got sort of that fan-like shape to them. These are also carnivorous mushrooms, which I appreciate. So sometimes you'll find little bugs in them, and the mushroom's eating the bugs. They're super cool. On the right-hand side are angel wings. Angel wings superficially look like oysters, but are found on softwood. So there's a good indicator without knowing much more about them. Angel wings were traditionally taken to be edible, and some of you may have eaten them or still think of them as edible, and that's fine. There were some illnesses, I can't remember if there were deaths or just illnesses, but there was kind of a rash of illness linked to consumption of angel wings many years ago, decades now. So they're considered inedible. But oysters are fantastic, and again, super common if you have poplar. Gotta love hedgehogs. When I write about hedgehogs on PEI, people are like, what, did they escape from the pet shop? Mushrooms have all sorts of different spore-bearing surfaces. We looked at some folds and some gills and the sponges of some of the boletes. Hedgehogs have teeth-like spore-bearing surfaces. And a fantastic feature of them is all of our hedgehog cap and stem mushrooms, so not the ones growing off the sides of trees, but the ones growing from the ground are edible. So if you find a mushroom in your woodlot with those teeth on it growing from the ground, feel free to give it a try. There's one called northern tooth that grows on the sides of trees. It's considered inedible. It won't make you sick. It's just super bitter. I love this, appropriate for Prince Edward Island. Mushrooms grow in every format, and some mushrooms grow on other mushrooms. Lobster mushroom, the color of that outside is an infection of a different type of fungi. So these are two types of fungi growing together. The base mushroom will be either a brittlegill or a milk cap, and I didn't include those broad groups today in the interest of time. But there's a separate type of fungus that will infest brittle-gills or milk caps and turn either an unpalatable or an inedible mushroom into a delicacy. And this is what they look like. They look like lobster, right? That looks like a lobster part of it. You break them apart and they kind of look like that artificial, like crab meat, the colored pollock that you can buy in stores, but they do have a seafood taste. So for an alternative to seafood, for people that may not be allergic to seafood or choose not to eat it, lobster mushrooms are fantastic. I'll end just with a couple of medicinal mushrooms that I get a lot of questions about. This one's turkey tail. Remember we talked about it being one of the white rot fungi. Turkey tail decomposers, they're polypores. Polypore just means they have many pores underneath the cap. They have those beautiful colored bands on their cap. That's where they get the turkey tail name. This one is kind of blue and gray, but I've seen them with browns and reds on them as well. A key to turkey tails is underneath those pores should be so small that they're hard to identify with the naked eye. If the pores are larger, there's something else. I enjoy turkey tail tea. There is some good science and some increasing research supporting the role of turkey tail in boosting immunity, to the point that in some medical communities now, turkey tail is being recommended as an adjuvant, so something to add to your traditional treatment in cancer treatment. Not suggesting people stop cancer treatment and go with turkey tail, but some in the medical community are beginning to recognize its role in association with other medicine. And the last one that I wanted to include, because I get so many questions about it, of course, is chaga. Chaga, this is a good example of a fungus that's not a mushroom. All mushrooms are fungi, not all fungi are mushrooms. Chaga is a special type of unit, a special type of form that grows on the side primarily of birch trees, sometimes other trees in the birch family. It looks like burnt charcoal on the side of the tree. It's very, very hard, almost rock hard. When you break it open, it's golden yellow inside. I really enjoy it. I collect it, dry it, and again, use it as a winter tea, similar to turkey tail. There's some research showing that it is useful in boosting immunity and used in combination with other medical treatments. A thing to know about chaga, and it's useful to know, it can be tempting to assume that any natural product is just safe to use without any counter-indications, which of course isn't true. And chaga is a good example because it's high in oxalic acid. Oxalic acid binds to calcium in your body, and folks that have issues with kidney stones or that have been put on a kidney-friendly diet should minimize the intake of oxalates, oxalic acid. So this might not be a product for you. But for most of us, moderate consumption, as Helena says, moderation is key. Moderate consumption is not an issue. So with that, if you're thinking, holy cow, I'd like to know more about some of those or other mushrooms, on my website, PEIuntamed.com, if you go to the blog, there's a fungus profile section. In there, I've got a few dozen of our common PEI fungi talking about the ecology, edibility, and how to find and use them. And I hope that you can find some of these in your woodlots as well. Thank you.